Hi, we're going to do the confidence interval estimate for the mean in Excel. And for the mean variable, you need to select one of your quantitative variables. I'm going to use the hours variable in the fictitious data set. And the confidence interval estimate has a familiar form. It's the sample mean plus or minus the margin of error. And the margin of error is given by a z-value times the standard error, and the standard error is just the standard deviation over the square root of the sample size. So very simple formula, and that's what we'll do the calculation in Excel. Okay, so on the Excel spreadsheet, I have I did it twice. For the variable that I'm going to use, the hours variable, I have from the descriptive statistics, I have the mean and I have the standard deviation, right? So both of those items are needed for the confidence interval. The only thing that I don't have handy here is the z-value. So it's the same z-value as the same z-value we used in the confidence interval for the proportion. So yeah, I'll put that here. So this is z alpha over 2. Okay, so for a 95% confidence interval estimate, that leaves 5% of the distribution in the tails, and the confidence interval estimate uses 95% of the sampling distribution. So we need the cutoff value that separates the middle 95% of the distribution from the 5% in the tails. Like before, I'm going to choose that value of z that puts 2.5% of the data in the upper tail. So that means I have 97.5% of the data to the left of that value. Okay, so I need an Excel function. We've used it before. I'm going to use it again. It's the inverse. It's the norm inverse. So once you do the equal sign, you can use a function or do an equation in Excel, a formula of some type. I'm going to use a function here. So even though I could just select this, I could just click on that, but just in case you didn't use this function recently and it's not on display in your spreadsheet, you can click on f of x, the function. You can select the statistical category and scroll down to normal inverse. So the probability to the left of our z-value is 0.975. That puts 0.025 in the upper tail. The mean, oh, whoopsies, I didn't want to do that. The mean it's the standard normal, so the mean is 0, and the standard deviation is 1. So there's the z-value. So the z-value is here, so we're ready to, the mean is here, the standard deviation is here, so we're ready to calculate the margin of error. So the margin of error So the margin of error will be equal to this z-value times the standard deviation divided by, I need the square root of the sample size. The sample size is the count, which is n, which in this case is 100. So I could have divided it by 10, but if it weren't such a nice number, I would have needed the square root of that value. So that's it. There's the margin of error. And so now we're ready to identify the upper bound of the confidence interval and the lower bound. So the upper bound is going to be equal to the mean plus the margin of error. And the lower bound is equal to the mean minus the margin of error. So there's the there are the bounds for the confidence interval estimate. So if I select that, I can paste it onto this into the Word document, and now I have the confidence interval estimate for the hours worked per week by MCC students. And that's here, and so we'll finish this in this way that we finished, similar to what we did with the proportion confidence interval. You know, we'll make a sentence here and interpret what the meaning of the confidence interval is. Okay, so then that's it.